Hello students and welcome to the quick solution of All India Cast Test Series JEE Advanced 2020 Test 3A Paper 1 Code ENF Physics. Let's move to question number 1. In question number 1, a uniform rod of mass m, length L, hinged at a distance L by 4 from one of its ends as shown. Time period of rod of a small oscillation in vertical plane is. So we know that the time period of a physical pendulum is given by t is equal to 2 pi under root I by m into g into d. So in this case, the value of I is ml square by 12, that is about center of mass, moment of inertia, and the point of oscillation, it is a distance L by 4 from the center of mass. So m into L by 4 whole square, and the value of d from the center of mass, point of oscillation, is a distance L by 4. So if I substitute this data here, this comes out to be pi into under root of 7L by 3G. So option A is the correct answer. Let's move to question number 2. In question number 2, a closed capillary tube of uniform cross-sectional area is filled with an ideal gas. Temperature of gas at one end is 200 Kelvin and at other end is 400 Kelvin, and it varies linearly from one end to other. If pressure of gas is P0 and volume is V0, the number of moles contained in capillary is. We know that for an ideal gas we can write PV is equal to nRT. Since the pressure and volume of the gas is same, so their product is same, and as the temperature increase from one end to another end, then the N will decrease from one end to another end. So I can write this equation as P into volume I am writing as A into dx, that is equal to dN into R into T, and T we can write as a function of x as T0, that is the temperature at x equal to 0, plus TL is the temperature at x equal to L minus T0 divided by L into x, as the temperature is varying linearly from one end of the capillary tube to the other end. Let it is a distance x, this is x equal to 0 and this is x equal to L. So if I write this equation, then dN can be written as P0 into A divided by R into T. So that can be written as dx upon this T. So if I substitute this T from here and integrate from 0 to L, then the number of moles comes out to be P0 into V0 divided by TL minus T0 into R into ln TL by T0. So if I substitute the data, it comes out to be P0 into V0. TL is the 400 and T0 is 200. So the difference is 200 into R ln 400 by 200, that is 2. So option C is the correct answer. Let's move to question number 3. In question number 3, a source of sound S with natural frequency 640 Hz moves along a straight line separated from a stationary observer O by a distance L. If the frequency detected by the observer when source is closest to him is 1000 Hz, then ratio of velocity of source to the velocity of sound is. So the frequency detected by the observer is 1000 Hz when the source is closest to him. It means that source must be at this position, which is the closest distance from the observer, and at this instant frequency by the observer is 1000 Hz. So the pulse emitted by the source, which is received by the observer, must be emitted at this position. Let at this moment it makes an angle theta with this line. Let its frequency is n, then the frequency observed by the observer can be written as n dash is equal to n into v divided by v minus vs into cos theta. Also, we know that the time taken by the pulse to reach from this position to this position can be written as, this is L, this is theta, so this separation is L by sin theta, and the distance covered by the source is L cot theta. So the time taken by the pulse to reach from the source to the observer is same as the time taken by the source to reach from this position to this position. So I can say that L by sin theta, that is the distance covered by the pulse with the speed of sound v, that must be equal to the distance covered by the source, that is L cot theta, divided by its speed, that is Vs. So from this relation we can find that Vs is V into cos theta. So if I substitute the value of Vs here, then it comes out to be N divided by sine square theta. So let's substitute the data. The value of N dash is 1000. The value of N is 640 divided by sine square theta. So from here, the value of sine theta comes out to be 4 by 5 and cos theta comes out to be 3 by 5. Now in the question, I have to find out the ratio of velocity of source to the velocity of sound. So the ratio of velocity of source to the velocity of sound is equal to cos theta, which is equal to 3 by 5 or 0.6. So option B is the correct answer. Let's move to question number 4. In question number 4, two sound sources S1 and S2 are placed at a distance 3 lambda, where lambda is the wavelength of sound emitted by each source. A detector moves along a line AB on the screen placed at a distance d from source to detect the intensity of sound. If sound source S2 is leading by phase of 120 degree with respect to S1, then the location of nearest point from O where maximum intensity is observed is. Suppose if S1 and S2 are in phase, then we know that the path difference at this point O must be equal to 3 lambda and the phase difference must be equal to 6 lambda. But since S2 is leading by an angle of 120 degree with respect to S1, so in the vicinity of point O, there must be a point where the path difference must be equal to 3 lambda. So there is a point. So if I join this S2 with this point P and this S1 with also this point P, then since this capital D is very large as compared to this lambda, so these angles are nearly equal. So it is theta. If I take the projection of this 3 lambda on this line, then this is 3 lambda into cos theta. The phase difference due to this path difference, I can write 2 pi by lambda into 3 lambda cos theta, and since S2 is ahead by 120 degree, so I can write 2 pi by 3. So this must be equal to 6 pi. So on solving this equation, the value of cos theta comes out to be 8 by 9. Now suppose this distance is y, then we can say that tan theta is equal to y by capital D, and tan theta can be written as under root 17 by 8. So the value of y comes out to be under root 17 by 8 into D. So option C is the correct answer. Let's move to question number 5. In question number 5, two bodies of mass m and 2m, each having specific capacity S, are at temperatures 30 degrees Celsius and 90 degrees Celsius respectively. They are connected by a metal rod of length L, area of cross section A, and thermal conductivity K having negligible thermal capacity. Ignoring heat loss to surrounding, calculate time taken so that temperature of lighter body becomes 40 degrees Celsius. So if I analyze the situation, suppose there is the body whose mass is m and there is another body whose mass is 2m. So these two bodies are connected by a rod whose data is given in the question. Its length is L, cross-sectional area is A, thermal conductivity is K. Now, initial temperature of this body is 30 degrees Celsius and this body is at 90 degrees Celsius, and now they are connected by a rod. So if I calculate what is the final temperature of this system, then I can write Ms, let the final temperature is T, so T minus 30 is equal to minus 2m into S into T minus 90. So on solving this, the value of T comes out to be 70 degrees Celsius. So the final temperature of this combination is 70 degrees Celsius, but I have to calculate the time taken so that the temperature of lighter body becomes 40 degrees Celsius. So let at any time T, the temperature of this body becomes T1 and the temperature of this body becomes T2. So at that moment, if I write the equation of rate of heat flow, then I can write Ms dt1 by dt is equal to Ka by L into T2 minus T1. And for the second object, if I write the equation, minus 2m into s into dt2 by dt is equal to Ka by L into T2 minus T1. So if I multiply this equation by 2 and add these two equations, then I can write minus 2ms into d by dt of T2 minus T1, that is equal to 3 Ka by L into T2 minus T1. Further, I can write this in this way, minus 2msl by 3 Ka into d of T2 minus T1 divided by T2 minus T1, that is equal to dt. So at T equal to 0, the temperature difference between these two objects is 60 degrees Celsius, and at time T, when its temperature reaches to 40 degrees Celsius, then from this equation we can find out the temperature of this body. It comes out to be 85 degrees Celsius. So the temperature difference between them is 45 degrees Celsius. So if I solve this equation, then the value of T comes out to be 2msl divided by 3 Ka ln 4 by 3. So option A is the correct answer. Let's move to question number 6. In question number 6, a spherical shell has inner radius r and outer radius b. Temperature of the inner and outer surfaces are maintained at T1 and T2 respectively. What should be the radius r so that the temperature gradient near the inner surface is minimum under the given conditions? So this is a spherical shell. Its inner radius is given as r and the outer radius is given as b. The temperature of this surface is T1 and the temperature of this surface is T2. So the thermal conductivity of this material is let K. So we know that the equivalent thermal resistance of this combination is given by 1 divided by 4 pi K into R2 minus R1 divided by R1 R2. So in this case I can write B minus R divided by BR. So the rate of heat flow is given by Ka dt by dx or dt by dr. So I can write from here the rate of heat flow is K into A. So area is 4 pi r square into dt by dr, that is the temperature gradient. That must be equal to the temperature difference between this surface and this surface. So that is T1 minus T2. Let I have considered T1 is greater than T2 divided by R equivalent. So R equivalent is B minus R into 4 pi K into BR. So if I solve this equation, the value of dt by dr comes out to be T1 minus T2 into B divided by B minus R into R. Since this function is maximum at R equal to B by 2, then we can say that this function is minimum at R equal to B by 2. So option A is the correct answer. Let's move to the first paragraph containing question number 7, 8 and 9.